next example because we're going to need at least the time remaining in this morning. Okay, so I'd like to begin by opening up the model that we had built 2 days ago or 3 days ago involving diabetes and weight status. Now, for those who feel more comfortable downloading the one from online, it was the initial interacting state charts version 2. Okay. Alternatively, you could end up using your own. Okay. So I'm just going to go open it up for mine too. Okay. Here we are. So you can download it if you'd like, or otherwise you can open up your own version of it. Okay. So just to remind us what was in this model, it consisted of 2 state charts, one related to weight, one related to diabetes. And we had interactions between these implemented where we had weights that enhance the risk of becoming diabetic. Do you remember that? Yeah. How was that interaction accomplished? How was it that your current weight ended up elevating your risk, or ended up impacting your risk for developing diabetes? Does anyone remember? Through the variables? Yeah. Through this variable, developing diabetes hazard contribution for current weight. Now, later I'm hoping to show you a model where that's expanded in a more fulsome way. But today I wanted to use this model as the basics for, as a basic foundation for putting in place some health economic factors, okay? So I'd like to save this model with a new name, which is going to be called health, so initial health economics, and I'm going to call it version 1, okay? Initial health economics V1. Okay, so I just did this here, and we're going to elaborate it with several features. So these models that we're building here, these dynamic models, they are associated with, they depict a set of interacting processes that govern the evolution of the model. But they often depict other types of processes as well, reporting processes, which are epiphenomenal. That is, they don't end up affecting the dynamics of the model, but they simply report on it. And we saw that in the last model, right, where we put in place this weekly reporting event, and it was reporting on a weekly basis what was going on. And it's quite common that we'll have certain of the events, even state charts potentially, other types of mechanisms in the model which exist for reporting. And in this case, we'll actually see some system dynamics quantities, some stocks and flows used for reporting. One of the good pieces of news about these models is that they can be used to pursue health economic inquiry in a fairly ready fashion. And you can layer on the models, as it were, health economic considerations in a fairly straightforward way. So we're going to take this model that we built earlier without in any way privileging it, without in any way viewing it as kind of a sophisticated model, but it does have a couple components that I wanted to illustrate, including the ability to take into account some of the basics and the ability take into account comorbid conditions. So what we're going to put into place is some basic infrastructure to keep track of costs and quality of life measures for this model based on people's health status with respect to both diabetes and weight together. And we're going to be reporting on factors related to that for the sake of model outcomes. Okay, so accumulated cost, accumulated QOLs, quality adjusted life years lived, as well as discounted costs and life years lived. This will also put us into a position to compute incremental cost effectiveness ratios between different interventions. Okay. Okay. So, ladies and gentlemen, what I'd like to do is to start layering in some components for quality of life and for costs. Okay. So, oops. Uh-oh. No. Okay. No, there we go. Okay. So the idea here is that we're going to have accumulating in main a set of quantities for accumulated costs, discounted, undiscounted, accumulated QOLs, discounted, undiscounted, accumulated life years. So I would like to put in place some mechanisms that we're going to associate some activity-based costing with each of these states now that are going to be characterizing costs borne in those states and potentially costs that are borne by certain events. For example, if there were a transplant event or a type of investigation that yielded a diagnosis using an MRI, we might want to keep track of those costs. Okay? For now, though, we're going to focus our attention on some quality of life measures. And we are going to have a quality of life measure which takes into account the dual quality of life associated with these joint categories, okay? And that's going to require a little bit more mechanism than if we were just to consider only one category. Suppose we were to consider one category. How would we keep track of quality of life a person is currently experiencing? Suppose there were only weight or only diabetes. Let's say only diabetes. How could we keep track of, at any one point, the quality of life associated with an individual? Suppose we have quality of life information about normal glycemic individuals and diabetic. What could we do to at any one point know what the quality of life is associated with a given person? Yeah, we can have a variable, just like we did for color, just like we did for interacting state charts with the hazard rate, right? Pretty straightforward. But if we have two sets of categories, it's less immediately obvious. So we're going to pursue a strategy that will allow us to do this in a fairly straightforward way. It's not incredibly beautiful, but it's not incredibly hideous either. Okay. So I would like to drag in something that Jeff, did you say something? No? Okay. Yes.
Just your transition there between diabetic is a timeout.
Oh gosh, no! It should be a rate transition. That's what the heck? It was this. Uh-oh. Kind of makes me wonder. Did anyone download it from the site?
Yeah, I think it's fine. It's a rate.
Yeah.
It was a rate?
Yeah.
Okay, I was probably showing somebody something, and I just frobbed it.
You may have just scrolled your mouse when the thing was selected and it changed.
That's also true. So watch this. If this is selected, you can go like this. Oh no,
Sometimes
it just
I don't know.
yeah. So notice that AnyLogic does remember like the settings for these. So if you specify this one and you switch to another, then you switch back, it remembers it, which is kind of a bug, kind of a feature. I think it's kind of a feature, but anyway, it has the trade-offs. Okay, fine. So this is a rate transition. Okay, So what we're going to do is we're going to put in place, ladies and gentlemen, a variable that's going to be called its name is going to be quality of life for diabetic by weight. And this is going to specify for each weight category, someone who's diabetic, what their quality of life will be. Okay? And its type will be other here, and it will specifically be a double array. And what that means is kind of a vector of doubles. It will have several elements in it. A first element, a second element, and a third element. Okay? And we call the first element at location 0, 1, and 2 successively. Okay, so we're going to put in place here this vector of sorts. It's going to be 0.7, 0.6, and 0.5. Okay? What that means is if they're normal and underweight, they'll have a quality of life of 0.7. If they're overweight, 0.6, and otherwise 0.5. Okay? And these numbers are not based on literature. They're numbers that we created in an exercise at one point. Okay? So that's quality of life for diabetic by weight. And then we're going to have a very similar quality of life for normal glycemic by weight. And ladies and gentlemen, if you want to do this, there's several ways you could copy, paste. I like to click while I'm holding down the control key and drag, and it will actually duplicate it like that. And you don't have to worry about where it goes, whether it goes. So here, you can click on this, hold down the control key on PCs, and then drag. I don't know what it is on the Mac. You hold down Command or Option maybe. Okay. So this would be quality of life for normal glycemic by weight. Okay, and this one is going to be very similar in its overall features, but it's going to be 1.0, 0.9, and 0.7. Okay. So the idea here is we're specifying two vectors. One vector gives the quality of life for different levels of weight if someone's normal glycemic. The other gives quality of life for different levels of weight if someone's diabetic. Okay? And then there's going to be a quality of life function. A function that we can ask from someone, what's your quality of life? And this quality of life function, its job in life is going to be to return a value. Remember, functions come in two sorts in AnyLogic. One sort does something, it performs an action, and it doesn't return anything. It's what we call a command as a type of function. The other, ladies and gentlemen, returns a value. And this is going to be one that returns a value. And the value it returns will be the quality of life for that individual. Okay? It's not going to take any arguments. In other words, it doesn't need any information to do its job. And it's going to have a very simple structure. Basically, if this person is diabetic, it will return something appropriate for their weight. And if they're not diabetic, it will return the appropriate thing for that weight. Okay, now, we're going to come back to this, but first we're going to figure out, well, no, maybe we'll fill it out right now, and then you'll tell me how we do the final step, okay? So we're going to say, I want to say if I am in a diabetes state. How am I going to ask that? How would I ask, am I in a diabetes state? Yeah, if this dot in state, if I'm in state, and to do it in a way that's robust on an ongoing basis, we'd say person.diabetic. After all, there could be, I have a colleague at U of S who studies diabetic dogs. And so we want to be diabetes with respect to person. Okay. And if they're diabetic, we're going to return the quality of life, this is just the variables we put in. What do you think it will be? Suppose we know their weight and we know they're diabetic. What are we going to return? How are we going to get their quality of life? Yeah, we're going to look it up in here because this is the quality of life for diabetes, for diabetic individuals. Quality of life for diabetic by weight. And we're going to look up for their weight what it is. Now, there's several ways that we could keep track of this. I'm just going to say weight index. And someone who's really smart is going to fill that in a bit. And that person is you. How you keep track of weight index, okay? And then we're going to say else. What do you think, if I'm not diabetic, how do you think I'm going to report their weight, their quality of life? What am I going to look it up in? For normal glycemic, yeah. So we'll say quality of life for normal glycemic by weight, and it's going to say weight index, okay? Now, my observation is, maybe I'm wrong, but my observation is that people are actually using autocomplete a lot this boot camp.
I think so.
Man, you folks deserve like 5 gold stars. The TAs, maybe they should take you to dinner or something. No, this is like night and day compared to some past boot camps where people are not using autocomplete, and half the TA's job is going and correcting a missing C, or you're missing a vowel or something. Okay, so this is what we want, ladies and gentlemen. You folks are doing a great job, and I really appreciate it. Okay, so we're going to look up for their current weight. So if they're diabetic, we're going to return the quality of life index, the health-related quality of life measure for their current weight from this quality of life for diabetic. If they're not diabetic, we're going to look up the comparable weight in the normal glycemic. Does that make sense? So yeah, it would be nice to have an array. It'd be nice to have a matrix. Which gives it. But it turns out it's kind of easier to do this way and probably a bit clearer, as long as we don't have too many categories. Yes, we would do it with a matrix if we had many categories here, not just diabetic, non-diabetic, maybe more than 3. We'd start to use a matrix. Anyway, okay. Now, how are we going to keep track of their weight index? We want it to be 0 if it's normal and underweight. Overweight, we want it to be 1. Obese, we want it to be 2. How would we have a thing called weight index that if they're here it's 0, here it's 1, here it's 2? What could we do?
Just have a variable. We
could have a variable. A variable. Okay, great. And it's going to be called what? Weight index. Good. Oops. That should be weight index. Imagine if the TA set to correct that every time it happened. Weight index. Okay, what sort of variable will it be? Be an integer, because it's 0, 1, 2. Okay, great. And its initial value will be -1. Or if it's never set, we will know about it. Okay? Okay, now where does it need to be set? In the health states. Man, you folks are good. Okay, normal and underweight. And we're going to do this dot weight index. Oops, weight index. Hey, I said his dot weight index. Okay. Oh my gosh. Okay. Okay, thanks. Yeah, well, I appreciate it. It's urging. Okay. Somehow I frobbed the wrong key here. Okay. This dot weight index equals 0. Okay. And then for overweight, we'll set dot weight index 1. That's the second one. And then obese, this dot weight index equals 2. Okay? Okay, great. Ladies and gentlemen, now we've got quality of life in place. And we're going to hitch it up to the grander machinery, okay? So, ladies and gentlemen, we are going to now go and, oh gosh, this would be interesting. I could, yeah. Okay, ladies and gentlemen, we're going to go and put into place some mechanisms at the level of the entire population to accumulate quality of life. But before we do that, ladies and gentlemen, I'd actually like to put in place a visual feedback mechanism, okay? Okay, so here we go, right. Good. Okay, so we're going to go to this oval, and we're going to change its appearance. Right now, its appearance depends on this dot color, but we're going to make actually that no longer be the center of the circle. We're going to instead have the color variable set the ring, the outer ring of the circle, the border of it. And to do that, we're going to go up to this circle. We're going to go down to fill color. We're going to copy from there, and we're going to copy it over, ladies and gentlemen, to line color. That'll be the line color. And we're going to set the line width to be 4, no less. Okay, 4. It's going to have a thick annulus around it. Okay, a bit like the annuli associated with the tokamak that Kurt used to study. Okay.
I never heard that word in relation to tokamak.
Okay, well, it's a 3-dimensional. Yeah. Okay. Okay, ladies and gentlemen. So for the fill color, we're going to do something different. And we're going to put in place a mechanism of which Dylan and I are both fond, but which few AnyLogic programmers, AnyLogic model creators are aware, of which they are aware. Okay? So for the fill color, we're going to do the following. We're going to say lerp color. Okay? No, that is not an MIT-ism. Okay? And we're going to, and so the lerp is going to interpolate between two colors. Okay? It's going to go from one color to another. And in this case, the from color is going to be white, and the to color is going to be red. Okay? Actually, it's going to be green. The fraction is going to be how far along they are between 0 and 1. And guess what we're going to put there? What sort of measure lies between 0 and 1? The health-related quality of life. Someone's quality of life. My quality of life. So the higher my quality of life, what color am I going to be? Green. Oh, and let's make the from color, let's make it red. What do you think? So we'll go from red to green?
We have to have it extreme red as well.
Oh, well, okay, so we'll do white to green. That sounds fine. The greener they are, the better their quality of life. Now, my thing is complaining about it's happy. Let's go use this as a teacher. Oh, no, it's a build completed successfully. So lerp. So what is this going to do? Well, depending on how close quality of life, or the value of quality of life, it's going to pick a color between white, ladies and gentlemen, and green. If quality of life is closer to 1, it'll tend to be greener. Quality of life is closer to 0, tend to be whiter. At the extremes, it'll be, at quality of life equals 1, it'll be all green. At quality of life equals 0, it'll be all white. Okay? Okay. Great. Great. Sorry?
It would just be different shades of green. No one's done it.
Yeah, be different shades of green. That's true. That's true. Okay, ladies and gentlemen, we see something like this. Okay, so here's some obese diabetics. Some So red is diabetic, yes. You remember the circle size is proportional to weight, and then this green color indicates quality of life. So what broad patterns do you see? There's a lot of people. Yeah, that's true. So there's a larger number of people with less high quality of life who are diabetic, and then there's some people who are lower weight and who tend not to be diabetic with fairly high quality of life here, that are sort of dark green, right? Okay. Okay. So that's a start, but now we're going to put in place the more global mechanisms. Now we're going to put in place some mechanisms at the level of the population. Okay, so ladies and gentlemen, I would like to put into place in Maine as a starter. We're going to have a total up over the population. Actually, we'll have in Maine an average over the population of quality of life. How would I compute that in a very nice, crisp, declarative way that's that we've done before? Statistics. Ladies and gentlemen, statistics. I tell you, statistics. Okay, this is great. So let's go to population, and let's go down to statistics. And we're going to put into place here average quality of life. Okay? And I'd like you to tell me what to type. Sorry? Okay, is it an average, a sum, or?
It's an average.
Average over item dot QOL. Yeah, QOL. There we go. Average of the QOL. Okay, now you'll notice with condition we could restrict it. For example, we could have it only be applicable for women or only applicable for younger folk. And that would be one way we could restrict it to different subsets of the population.
Could you use that to break out the quality of life in different states?
Could you use it to?
I know, you needed to, never mind, sorry.
Yeah. Okay. So ladies and gentlemen, now we're going to put in place a different one, and this is going to be. This might puzzle you. It's going to be total QOL, and this is going to total up across all people in the population their quality of life. How would I do that? What sort of type would I do? Sum. And what would I sum up? Same. Okay? Same idea. Summing it up. Great. Okay, now I'm going to put in place a construct that's going to perhaps be unfamiliar to you. So I'd like to go to the palette, ladies and gentlemen, and I'd like to introduce you to an yet as untapped area of the palette. And it lies just below the drop. It is called system dynamics. Okay? I'd like you to drag in a stock called life years. Well, we could call it life years lived by the population. Okay? And there's going to be a flow into the stock. The stock is going to represent an accumulation, and its initial value should be 0. Okay? The initial value of that stock should be 0. That's the default initial. The flow in is going to be called new life years. New life years. Now, I'm going to tell you what the value of the flow is. So with system dynamics, you build a model up out of two basic types of components. There's some ones that are sort of that are shorthand for combinations of them. But basically you have stocks, which are accumulations, and all you specify for them is their initial value. And after that, their value is dictated by flows. Flows in and flows out of them. If the flows in total up to more than the flows out, the stock will be tending to rise. It's kind of like you have a bathtub and water is coming in faster than it's going out. So the bathtub level will tend to go up. By contrast, if the sum of the flows in is less than the sum of the flows out, the water in the bathtub will tend to sink, will tend to go down. The water is rushing out faster than it's coming in. Okay? And if you turn off that water into the tub altogether, and you just have water going out, that tub will be draining. So stocks are accumulations that are shaped by the flows into and out of them. Flows in is greater than flows out, they rise, flows in, and less than flows out, they'll tend to shrink. They're a way to capture continuous quantities. This is of great note when it comes to hybrid modeling. And we will see cases where these are used to characterize the dynamics of continuous quantities, things like weight level, your level of immune activation, your risk perception, your level of addiction to e-cigarettes or cigarettes, your attitude towards in terms of trust towards the healthcare system. And it turns out system dynamics excels at focusing on models which exhibit feedback. So it's really a methodology centered around feedback systems and the concepts of feedback and accumulation. So this is an accumulation. And coming into this accumulation is the flow corresponding to new life years. And at any one time, this is going to be summing this up over time, or at a more mathematical level, for those for whom this is meaningful, it's going to be integrating this up. So if there's one person who lives 50 years in the model, the number of life years lived is going to integrate up. It's going to be summing up. You know, that person's going to live, it's going to be one person, and it's going to sum up one person over those 50 years, integrate them up, and it's going to be 50 life years lived. By contrast, if there's 50 people and they only live 1 year in the model, it's also going to be 50. It's going to be the number of life years that they've lived in the model. The way that we do this is we actually integrate up the population size. So we actually are going to sum up the population size over time. So new life years here is going to be nothing more than this dot population dot size, ladies and gentlemen. If the population has no one in it, that's going to be no life years lived. If there's one person in it and they're living 50 years, it's going to be 50. If there's 10 people in it and they're living 5 years, it's going to be 50. If there's 10 people in it and living 20 years, it's going to be 200. Okay? So that's what it is. This is going to be life years lived. So the stock, in general, it's just going to depend on the values of its initial value, and then it'll change after that based on the values of flows into and out of it. Now, in general, for a system dynamics model, the values of the flows will depend on the values of the stocks at this current time. How the system changes over time depends on the current state of the system. And in that sense, it's not deeply different than with agent-based modeling, discrete event modeling, where what's going to go on in the next little bit of time is dictated by the current state. Think about, if there's a person who's in a normal and underweight state, whether or not that's going to dictate the fact that they have a chance of becoming overweight in the next little bit of time. The current state of the model, what state people are in, is going to dictate a lot about what's going to happen next. If there's an infectious person what may happen next is other people can get infected in an agent-based model. It's the same thing here, but it's a little bit more explicit because we'll actually make clear connections between the state and the flows. In this case, though, this flow is just going to flow in to this stock according to the number of people in the population. So we're going to run this model, and we're going to see life years accumulate in this population. Okay, so here we go. Here's our life years lived, and they are accumulating. And here we go. Life years lived is rising in this population. Okay, and we could simulate it out even further. And you folks can't entirely see it, but there's a little bit of a curvilinear component to this. It's not entirely clear, but it reflects the fact that a growing number of people are becoming diabetic. So we have life years lived, and they are accumulating here. System dynamics is notable for having a very declarative style of model. You're not writing for loops or if statements in the middle of code. You're simply giving formulae for the flows that depend on the values of the stocks at the current time. And yes, a flow can depend on another flow, but ultimately that depends on a stock. Okay, so the current state of the system is dictating its future evolution, and of course, stocks are driven by the flows into and out of them. So stocks are determined by flows, and flows determined by the current state of stocks. Yeah. Yeah.
This flow is determined by the model time that you've set, so it just automatically does a delete. So
this is integrating up this, and the time which, how frequently it's actually adding that in, how finely it's doing the numerical integration is going to be dictated over here by the model by numerical methods, and in fact the methods that it uses and the time step that it uses. I would have to double check my understanding, but I believe it's by this component here that dictates how finely that numerical integration is being done. So if I change it to this, it'll be done every 0.1 of a year. Here it's every 1,000th of a year, so it's like 3 times a day.
That's what I don't understand. Is it adding the whole population size in every
No.
10th of a year? Because then you're getting a 10.
It's integrating it, and so what that means is it's taking into account. So if it's doing it at a very fine time step, that time step is going to be the dt in the integration, the small increment of time, and what it's actually summing up is these dt's times the current value of this. Okay, so the current value here was set by this population.size, and what it's going to be summing up over time, what it's going to be adding up is the value of this flow times the time step, which is this integration time step 0.001, and it's going to be adding those up every over time. And maybe the best way to do it is to show this. I'll show you. Okay, so watch this. We're going to draw, so this is a great little chance to explain this. I'm going to draw a simple stock here and a flow into it, okay? And, oops, hey, come on. This flow, okay. So here's the stock and a flow. And this is going to start at 0, and I'm going to have a flow in here of, let's say, 1 initially, okay? And I'm going to run this model out for 1 time unit. And so in order to do that nicely, I'm going to create a new experiment, which is going to be single year. Okay, it's going to be a single year, and it will go from time 0 to stop at specified time 1. Okay, so I just created a new experiment. It's going to represent a single year. And here, going to be integrating this up, and in the course of a single year, this is going to go up to a value of exactly 1. Okay, this is rows, and the reason is this is 1 at any time. It's adding it up over all these tiny, tiny time steps. For each time it's adding it in, it's adding it every 0.001 years. It's adding in 1 times 0.001. And so it's accumulating up over the course of the year this value of 1. It's almost like you had a faucet where it was coming in at 1 liter per minute, and you ran it for a minute, and so you get 1 liter out accumulated. If this flow were here, a flow of 10 over the course of that year, I will have accumulated 10 years lived, right? So it's 10 life years lived over the course of that year. Now, if we had this, instead of going just a single year, we had this going 10 years. Let's go add that in. So 10 years. And we went down and set this to stop at the specified time 10. We could run it here, and now we're getting a flow of 10 in over the course of 10 years, and it's 100. So it's doing an accumulation of this, but on very, very fine time steps. Why is that? Because this number of new life years could be varying if there were birth and death in the model. It could actually be changing. And actually, in this case, I was wrong. This is just totally up life years, so it's just based on the population size, which in this case is fixed. Thought I saw some evidence of it bending, but no, that's wrong. Can't be, because it's a fixed time step. So this flow is constant right now, flow in. But if we had mortality, it would be changing, right? So let's go for the kicker here. So we're going to go to main, and we are actually going to change this to have a stock. Hey, I thought, oh man, I thought I deleted both. Okay, hey, come on, get rid of this. Hey, come on. I just clicked on its center, and I went to the heart of the matter and deleted it. Okay, this will be QOLs lived. These are quality adjusted life years lived. And here we go. And this is going to be new QOLs, okay? And here, what this is going to depend on, instead of just the population size, it's going to be this dot population dot total QOL. The total up of the quality adjusted life year. So if there's half the population with 0.5 quality of life and half with 1, and it's a population of size 1,000, then we're going to have 500, or let's say, to simplify it, a population of size 2,000. We're going to have 1,000 people at 0.5, 1,000 people at 1. So it's going to be 1,500 quality of life totaled up, and we're going to be summing them up across the span of the model. So this new QOLs is going to reflect that not everyone is living a fully high quality life. Some are living at half the level of quality of life that others are, say, and as a result, the number of new QOLs lived in the course of a given year may be smaller than the number of life years lived. So if we're running this now we're going to see, hey, oh man, -1. Oh, what the heck? Okay.
Does anybody know what quality is?
This is a quality adjusted life year.
Right.
So it's a life year weighted by quality of life.
Right. So one quality is equal to 1 year at perfect health.
At perfect health.
Yeah.
And if you have a quality of life of 0.5, you will have, over the course of that year, accumulated QOLs of 0.5. Yeah. Okay, ladies and gentlemen, did I forget to set the weight index here? Okay, no. Okay, so why is it that I am getting -1? This is fascinating. Neat.
Your initial value for weight index in the variable is -1.
I know it is, but why would this should always be Oh,
The fox has shown its tail.
yes, but what a devious fox it is. Mumble. Okay, I have a hypothesis, but it's the most unpalatable hypothesis. It's like look at it first before this gets initialized, which would be the most unpalatable thing, because that violates my mental model of what should be going on. Okay, so suppose I set initial value to 0. And we were to do that. Now it's a happy camper. Gosh, that really troubles me. I'm distressed by that. Okay, now we see this curvilinear character. Okay, I'm distressed. Why would it be calculating that?
You're using.
I guess it depends on the ordering at time 0 of events. That's the only thing. Which event gets updated first? Is it the statistic gets called by the chart first, or does it enter the state chart first? Oh man, I really dislike that. That bothers me a great deal. Okay. In any case, let's run this for 10 years, and we should see a number of QOLs that are accumulated that are reflected of the imperfect health of the population. We have 1,000 people in the population, and over the course of those 10 years, if they were all in perfect health, we would have expected 10,000 quality adjusted life years to be accumulated. But instead, we see 9,700 or so accumulated. Now, if we ran this out for 20 years, I'll make a copy here, and we ran it out for 20 years. Here we go. So this would be 20 years. I'm going to adjust it so the model time runs from 0 to 20 rather. Notice that you can go into an experiment. So I added a new experiment. You can add a new experiment. I think I copied that one, but you can add a new experiment. And then going down to the time area of that experiment, model time, you can set it to be I set it to stop at specified time, go from 0 to 20. Okay, and then I'm going to run it here. Here's over 20 years. If they were in perfect health, what should it be? 20,000. We're running it out, and it's 18,700. And there you can start to see that slightly curvilinear character. It's not accumulating quite straight because a growing number of people are becoming diabetic and developing overweight. Okay, we're going to run it out now for 50 years. New experiment, and I'm going to say 50 years. Okay? Now, over 50 years, we'd expect an even larger set to become diabetic and to develop overweight. So I just did it, stop at specified time and under model time, start time 0, stop time 50. I'm going to run it out. Okay. Here we go. And there we go. And we're falling significantly short of the theoretic thing we'd get with perfect health, which would be 50,000. We're almost down to 40,000. Now you could really start to see that. Okay, so ladies and gentlemen, if this model had mortality in it and we could readily put it in, we could take that into account in the natality. So this is quality adjusted life years lived. To recap, what I did is I went into Maine. Well, I went into person and this quality of life measure, and then I went into Maine and I had population, and here we had a total QOL, which sum up across the entire population the total quality of life experience. So again, if half the population had 0.5, half had 1, it will be a total QOL across the population of the population size times 0.75. And those are the number of new life years, and it's integrating those over time. It's summing them up over time, taking into account the fractions of the year involved for which they apply. And so that's going to go into quality adjusted life years lived. Okay, now, ladies and gentlemen, what I'd like you to do now is we're going to put in place some measures for costs. So I'd like you to go down to the, again, to person, and we're going to put in place some cost measures, okay?
Is this a good time to build and save if we're in trouble?
Sure.
Discuss now?
And in fact,
Because the next part is significant.
maybe what I'll do is upload this at this point too. This is version 0, and I will go upload it, and I will stop the recording. There we are. Okay, it's up on the site if anyone wants it, version 1, and I'm going to stop the recording.